Hi. Welcome. I know why you're here, and it's not to learn calculus. It's to join me in the simultaneous sip. So if you have your coffee ready, please join me. The question we're working on today is, sketch the graph of the function f of x equals sine of x plus cosine of x. So the function we want to graph is f of x equals sine of x plus cosine of x. So we'll start with the domain. The domain is all real numbers, so negative infinity to infinity. Now the x-intercept. So we'll set sine of x plus cosine of x equal to 0. We can rearrange the equation to get tangent of x equals negative 1. So x is equal to 3 pi over 4 plus some integer times pi. The y-intercept, we just substitute x equals 0 and solve, so we get the point 0, 1. Next is symmetry. Well, we have trig functions, so it's going to be periodic, and the period of this function is 2 pi. So instead of looking at the interval negative infinity to infinity, we could restrict our attention for x between 0 and 2 pi. Asymptotes is next. There's no vertical asymptotes because our domain is all real numbers. And you could see that the limit as x goes to infinity or negative infinity of f of x does not exist, so there's no horizontal asymptotes either. Next is the intervals of increase or decrease. So we have to take the derivative, which is cosine of x minus sine of x, and we'll set it equal to 0 or find where it doesn't exist. It simplifies to tan x equals 1, and so we get x equals pi over 4 or 5 pi over 4. So we'll take our number line, break it up at pi over 4 and 5 pi over 4, and take some test values. And we'll plug our test values into the derivative to see if they're positive or negative. If the derivative is positive, then our function is increasing. If the derivative is negative, then our function is decreasing. So we're increasing, then decreasing, then increasing, which means we have a local max at the point pi over 4 square root of 2, and a local min at the point 5 pi over 4 negative square root of 2. Now would be a good time to pause the video and comment below what your favorite part of sketching trig functions is. Mine is remembering the unit circle. And while you're down there, why don't you smash that like button and subscribe? Alright, back to the show. So now we could find the concavity, and to do that we need the second derivative, which is negative sine of x minus cosine of x. We'll set it equal to 0, and we get tan of x equals negative 1, so x equals 3 pi over 4 or 7 pi over 4. Again, we're going to write out our number line, break it up at our values that we just found, and take a test value in each of these segments. And then we'll plug our test values into the second derivative to check if it's positive or negative. If the second derivative is positive, then we're concave up. If the second derivative is negative, then our graph is concave down. So we have concave down, concave up, concave down. We could see we have a point of inflection at 3 pi over 4 comma 0 and 7 pi over 4 comma 0. And now we're ready to put it all together. So we'll take our number line, break it up at every spot that we've broken it up along the way, and give a quick little sketch of what our curve will look like. All right, and now it's time to put it all together and connect the dots. And you can see on the right, this is what the curve looks like with the help of Desmos. And our drawing is really not that bad. Well, thanks for stopping by. I'll see you next time. Don't text and drive. Bye-bye.